Hello, hello, total developers, back again with another video. And today we will finally be going over and implementing the Polybius cipher in Rust, right? So we are like usual, we already have the tests written. So let's get started, right? So first things first, right? We need an encode function, right? And just a little caveat here is I have a char map as you might know from the previous video explaining about the cipher. There's a Polybius square, right? And each character is matched to matrix coordinates, right? So regardless, I have a hard-coded char map that I'm going to copy and paste into this project just because I want to save on time, right? So anyways, so let's get started, right? So obviously we need to an encode function, right? So we need to encode an ASCII string into its location in the Libya square, right? So we also only want the alphabetical characters to be encoded, right? So let's go ahead and specify that, right? So we only want, that's a caveat here. So we only want the alphabetic characters to be encoded. And yeah, let's get started. So first things first, let's define a function, right? So pub fn encode as the Rust language dictates, right? So let's encode the ASCII. We need an input of type string, right? And we need to return a string, right? So we could just say string, right, of type string, and it's going to be a reference to that string. And you can see the AI is filling out its own version of it, but we have our own version that we're just going to copy and paste, just for simplicity. Awesome, right? So what we're going to do now is take that parameter string, right? And then we're going to cast it to a character array with chars, function chars. And then we're going to or loop through it with the map function, right? Take each character as C and then match it to a position in the character map. And we have that already hard coded here, right? So that looks like this. All right, and as we do this, right, we have lowercase a's and uppercase a's all equaling 1, 1, right? B and uppercase B, 1, 2, and so on and so forth. And we have a default here that returns nothing or an empty string um, as um, as a safety or ignore um, capability of the function here, right? So, and at the end of this, we should call collect, right? And that should go ahead and return our character, character map or our encoded string based on each character in our input. Great. So once that's said and done, let's go ahead and create our decode function, right? So we need to decode that encoded string. So we're going to decode a string of integers into their corresponding ASCII characters, right? So, and then we also want any invalid characters to be ignored. So great. So let's go ahead and create that function. So pub then or pub public function decode ASCII, and we want that parameter to be called string, and we want the function to return a string at the end when it's all said and done. right? So how we go about this now is that we want to take that parameter string, we want to cast it to a character array, the chars function, then we want to filter through it, and then asking each for each character C, we're asking if it's, or we're checking if it's not a white space. So we say not C dot is white space. So we're checking, hey, is C a white space or not? And then we want to collect it, call collect, and then we want to make sure it's casted to a string, right? So that's done by this, and then we want to call that function. And then we want to say as bytes. So we want to make sure it's in byte formats, but that string gets converted to bytes at the end of that. And then we want to chunk it. And this is the beauty of Rust, right? These functions are all built in because it's so low level. And then we want to map it, right? So we want to essentially loop through all these byte chunks and map each chunk as a pair, right? And then when we do that, we want to essentially ask, match that standard. We're using the standard library here, standard string from utils, essentially casting that S from the chunks into UTF-8, right, as S. And as you can see, AI did something like this, but we want to delete this. We just want the gist of what's going on here, and we want to delete this. And now we just want to say, okay, if that V, okay, we're calling that V, and we're casting it to V, and then we want to say, as a function, we're going to parse whatever is casted or whatever the response from the match was. So if it's positive, we want to go into this function, and then we want to say, let's parse that positive input as an integer of 32, I32, uh, parse it as a casted I32 integer, and then we want to call that function, that parse function, and we're forcing it into the I32. And then we want to unwrap it or 0, and then our next catch, basically, if there's an error, just return 0. Now we want to map again on the results of that. And then let's go ahead and call our character map, right? We have this character map that we want to just basically match our values to, right? So that's going to look something like this. So for each integer in that map, we want to essentially just match it. It looks something like this. And then we want to collect it at the end. Get rid of this filter. And then we want that collect to be casted to a string, or we want it to be strictly a string. And then we want to replace any of the empty characters with an empty string, right? So let's go ahead and just use our function here, or our character map from our hard-coded value, and it looks all good. So let's go over it, right? Just as a double check, right? So we have our encode ASCII function, and it takes a string, a reference to a string, and then it returns a string. Great. Right. So as we go through this, we have our parameter string cast it to character array, right? Then we loop through it with the map for each character in that character array. We want to match C to a one of these values here. And then essentially if it's A, we return 11 or return 1, 1, all the way down to Z or whatever we want our input to be, right? And then each time it loops through this, it's going to return that integer representation of the letter, right? So if our message was, let's say, hello, we want to go through this character. This is going to be casted as a character array, and then we're going to go through each of the characters. So it's H. We have 23. So our function is going to return 23, right? Or character 23, or as a string literal, right? Plus E, which is 15, right? Which is 15, and then so on and so forth. And then it's gonna have this as our encoded value at the end, right? So that's just how that works. Nice. So now let's go to our decode function and just have a review of it. And that looks like this, right? So we're going to basically decode a string of integers into their corresponding ASCII characters, and then we want any invalid characters to be ignored. Great. So how does this work, right? So we have our public function decode ASCII, great. It has a parameter of string, great, and it's of type reference to a string, okay, and it returns a string, great. So what's happening here? So we have our parameter string. We're casting it to a character array, good. And then we have our filter, basically just filtering out or returning whatever the filter uh, condition is calling for, right? So we're saying, is any of these characters a white space? And if it is, if it's not a white space, we call this function, right? So this is going through every single character and asking if it's a white space. And if it isn't, we move on to the next step, right? So basically it's skipping all white spaces inside of our decoded or encoded string that we are planning to decode. Wonderful. So we collect all our results at the end of it, and we want to make sure it's of type string. And then we want to cast it to a byte, and then we chunk that bytes, or just essentially breaking it up into nice chunks of two. And then we map it or loop through it. All right. And then we call map of match, and then we're matching for standard characters of UTF-8, basically ASCII. And then from there, we are um, calling our OK function. So basically, once we do find a match, we run this, right? So in this, we're just taking that result from the match. So whatever the match is, we are parsing it and as a integer, right? And then we're going to unwrap it for later use, right? So basically, essentially unwrapping the object that's returned from this map. Um, Basically, this is why we have to unwrap it now. But anyways, so let's go to the map at the end, and this essentially gets whatever the integer that we are looping through, and then grabbing the ASCII or character representation of it, right? So 1 1 would be A, blah blah blah, all the way down to the last collect, which is forcing any of the integers to a string, and then we're replacing any of the white spaces with blank spaces. Basically, we're taking out the spaces. Great. So let's go ahead and run some tests here just to make sure everything was written correctly. It seems like we have an error here. Uh, so let's go through it. Let's try to debug this together. We have an error on line 36. It says this map S is expecting a, oh, I see. We did not close this this map function correctly, right? think so. Let's see. It says expected one or more operator while parsing this massive while parsing. Do 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 do. Let's see here. Oh, I see what happened. For our standard library, we we used a period. Let's see. Great. Wonderful, guys. So all our tests passed and we're good to go. Make sure you don't use the period here, right? I might be a bit used to Python from other experiments that I've been running. For the total developer team, we are now working in quant quantitative analysis and research. So I've been using a lot of Python recently. But with that being said, if you enjoyed the video, like, subscribe, and all the code will be on the blog. And till next time, guys, have a good one.